Hi friends, so let's start with our lab, which is creating a knowledge mining solution. So in this lab, we will create a knowledge mining solution, and we have set of documents maintained by Margie's Travel, a fictional travel agency. So we have a agency, fictional travel agency, and we will basically use AI search to index these documents, right? And I can show you what kind of documents are those. So these are the documents, like this is the Dubai brochure. So yeah, these are the documents. So let's see in these documents. First of all, what we have to do, we have to create an AI search, Azure AI search resource. For that, we will go to the AI search, right? And we will create one resource. So I am creating the resource. I am just showing you the process. I already have created my resource. So let's say we have a service name of lab something, lab search, ACS, right? You can name it anything. That will be a resource name, and this will be a resource group name. You can choose the existing one or create a new resource group. Then in pricing tier, you can choose the free pricing tier. The free pricing tier can be only chosen for one Azure AI search resource. So I already have it, so that's why when I will review and create, then it will say, that this cannot be. So let me show you. So validation in progress. So this cannot be created in free pricing tier. So that's why you can only create one AI search resource which is in free pricing tier. So what I will be using, I will be using already created, I have already created a search resource. So as you can see, service quota exceeded. Free service tier quota, you are using 1 out of 1 service, free tier service quota. So that is why I cannot use the free tier in this case. But you will be able to create a free tier if you do not have a already existing search resource. So I have already existing this search resource in which I have created some indexes. So here you can see we have option to add index. We can add index in JSON, right? Add index JSON. So here you can basically specify the name, the field names, the name of your index, what are the field names in the index, what is the type of each field name, and the key, right? So here you can add index like this, or you can add index and you can create your name here. You can add fields, right? Retrievable, searchable, sortable, facetable, and searchable. Don't call it facetable, but yeah, facetable, I think what you call it. Then this is the strings. You can have this different kind of EDM dot, complex type, boolean, int, right? Geography point, and then you have all those collections also, collection of all these, right? So this you can use the type, the configuration attributes, so like what each field is, like each field, do you want this field to be retrievable, sortable, searchable, right? So which search you want, it has different search. So standard is Lucene search that it uses, but you can also have a different kind of polished Lucene, right? Microsoft Russian Lucene. So this kind of analyzers are also available in the search. When we choose searchable, we can choose the analyzer also, right? Then this is facetable, sortable, filterable, retrievable, right? So all of these configuration attributes we will see, but like this is the field name, this is the type of that field, right? And here you can configure ID is the one of the, they have automatically generated it. Then there is encryption also. You can have Microsoft managed keys, or you can also have your own managed keys, right? You have to take from Azure Key Vault. So that is also an option. But right now we are not creating an index, but here is an option to create index. There is an option to import data. So you can import data here, right, from existing data source, right? Or you can import it from various, you can import it from SQL database, blob storage, table storage, Azure, SharePoint online, right? Microsoft OneLake, all of these things you can import from here. And then you can add cognitive skills also, customize your target index, create an indexer, right? So this is how you can add your data, add cognitive skills, and then create an indexer. So that indexer will create an index, right? So index is something which is there in the storage, but indexer is something that creates that index, right? So yes, so we have You can visualize interface to create, test, manage, and monitor various components of search solution, including data sources, indexes, indexer, and skill sets. Now what we have to go, we have to go to storage account. So now let's create a storage account resource in a new window, right? So we have to create a storage account, and then we have to use this storage account. Primary services Azure Blob Storage, and wait for deployment to complete. So let's go to azure.com, portal.azure.com. Let's wait for it. So now we will go to the word storage account, right? And we will create a new storage account. We will call it, so let's create a new storage account here. So these are the all the storage accounts, and we will create a new one. And let's put this into a new resource group. Let's put this into lab L2 resource group. So, and now let's give it the name. So we will name it search storage account. So that will be the name of the storage account. Number must be between 3 to 24. Okay. So is your storage account. Okay. Still storage account. Yes. So it works with your storage account. So that's why we can use only letters. This is already taken. Okay. So let's do search account storage. So search account storage, that will be the name of our storage account. And then the region, preferred type is Azure Blob Storage or Azure Data Lakes Gen 2, right? We will go with standard one. So standard one has general purpose. V2 has all of these like block, files, right? Tables, all of these are there. So now for the redundancy, we will choose local redundant because this is the one with least cost. And then here we can have the advanced settings, but we do not have to do any advanced settings, and we have to do nothing here, right? Enable soft delete everything. Encryption is Microsoft managed. Okay. Tags, no tags, and then we will review and create. Let's see, all of this has been taken care of. So now we will create this. After creating this, we have to download this file from zip file, save into a local folder, extract the file, and I have already done that. So these are the files that I showed you, right? And after that, we have to select blob container, create a new container with anonymous access level private. So we do not need any anonymous access, right? So let's go. And so right now it's in progress. So deployment has been completed. Let's go to our storage account. So this is our storage account. From here we will go to data storage and then go to containers. In containers we will create our new container and we will name it. There is default .logs container, and we will name our container as documents. So documents, we will not give any anonymous access, and we will create it. So now this container will be created. This container has successfully created, and now we will upload all the documents. Browse for files and downloads. In downloads we will go to documents, and these are our documents. So we will upload them into our container. Upload, and yeah, so all of these are uploaded. So now let's go to the next option, that is create and run an indexer. So for creating an indexer, we will go to our Azure AI Search resource, right? So here we have the Azure AI Search resource. here we will create on import data, right? And in import data, what we have to do, so we have a classic experience and a new experience. So we can choose any of the import data. So like this is a classic experience import data. If you want a new import data experience, so we will click on import data new. So this one is a new experience, right? So this one looks more good. So yeah, we can try both of, but let's see what have they tried, what they have asked us to do. So yeah, the instructions refers to the classic import data workflow. To avoid confusion, make sure import data from the toolbar. So they have used the classic version of it. So we will also use the classic version. Okay. So let's use the classic version to create an indexer, right? And now here we will choose our Azure Blob Storage as existing data storage and data source name. So what do we now want to name our data source? So on the connect your data page, so this is our connect your data page here, right? We have to in the data source list we have to choose Azure Blob Storage and then complete this with this. So data source name will be Margie's documents, right? So this is our Azure Blob Storage. We can choose another also, like we can choose from Cosmos DB, we can choose from SQL database, Azure SQL database, table storage, data lake storage, Gen, SQL server or Azure VMs. So all of this we can do, but we will not do that. Margie's documents, and then what data you want to extract. So you can only extract the or you can extract all the metadata, storage metadata only, or content and metadata. So here we will choose content and metadata. So content and data metadata means like from our content, which is like list of PDF files, right? So what we want to extract, we want to extract the content, that is whatever is in that PDF files, and also the metadata like file name and all those things. We want to extract both of those things, right? So this is the mostly used option, content and metadata. We do not want to just extract metadata and not the contents of the PDF file. So that's why the data to extract we have to allows you to specify which parts of blob are indexed. With larger files over size limits or unsupported file types, you should index storage metadata only. So let's see what this means. So I'm going here. So under configuration, set data to extract to control which parts of blobs are indexed. So in content and metadata, all the metadata and the textual content are extracted from the blobs, right? So from the blobs, all of this is extracted, all the metadata and the textual content. In storage metadata only, standard blob properties and user specified metadata are indexed. So if you want to take a look like what that will look like, so that might look like this. So you can have these kind of properties. What is the URI of container? What is the public access value for the container? What is the last modified? So these are the like container properties, right? Like the blobs container properties, right? So the storage container that we have, so it is basically the metadata of that container. Then in case of all metadata, it specifies all standard blob properties plus metadata found for found content type. So whatever the content type we have, we will have metadata for that also. So like for CSV we can have the content type and the content encoding. Then for doc we can have content type author, character count, creation date, page count, word count, right? And then similarly for all other types, for JSON we would have content encoding, right? Then there are other other types also. Like in plain text we also have metadata language. In PPTX we will have last date, slide count. In Word we will have author, creation date, right? So all of these depending on different document formats. So these are the document formats which are supported by Azure AI Search. So there are a lot like CSV is there, HTML, JSON is there, Microsoft Office, all the formats, open documents, PDF, RTF, XML, zip, all of these are supported document properties, right? So these are those properties which will come in all metadata will come standard blob properties and also the metadata for different content types. But in storage metadata there will be only blob properties or user specified metadata like key value pairs in the tags that we specify. So in storage metadata and all metadata, only we are talking about the metadata. But in content and metadata, we are talking about the metadata plus the content. So we do not have a use case in which we want just the metadata. So that is why we only specify the content plus metadata. So we want to extract this, and what was the data source name? So our data source name is this Margi document, right? We have to choose Azure Blob Storage, Margi documents, and content and metadata, then the parsing mode. So here, if we know that our document is just a text file or it's just a JSON file, so we can use a parsing mode. So then it will, if it is a JSON, then it will create each file for each object, right? Then it knows like how to parse it. There can be JSON array, JSON lines, right? So it know how to parse that. But if we do not have that kind of thing, a text or JSON lines or delimited text, then we will use default, because we have documents, a lot of documents of PDF documents, so we will choose default. So here in parsing mode we choose default. Then subscription is the subscription, and the next thing is connection string. So we'll choose an existing connection string and we will select our storage account and document. So let's click on choose an existing connection, and then there is a storage account. We will choose our storage account. So our storage account is for the lab L2, that is search account storage, and then we will choose our container. So our container is documents and select it. So we have connected. Now let's see the next thing. So choose manage identity authentication none. So we will choose this none. So what is this? So this is basically a manage identity on the search service. So this gives you an option to like authenticate. So like search service can authenticate to the storage account using manage identity. Right now we are choosing this to none. Okay. And then the container name and blob folder. So our container name is documents. We do not have to choose a folder because we are already in the documents have already the documents, right? And then in descriptions we will say travel brochures. So these are all travel brochures, that's why, right, we choose this. Now let's go to add cognitive skills. So that is optional, but that is the whole point, to add uh, like additional metadata, right? So for that, now we will choose add cognitive skills, and which has 3 expandable sections to complete. Okay, so here we can attach AI services, add enrichments, and save enrichments to knowledge store, right? So let's see what we have to do here. First of all, let's go to attach AI services, right? Here we should know that to power our cognitive skills, we have to select existing AI service resource or create a new one. So we can attach our existing resources like AI resources to this one, or we can create a new one. So here you can see when we click on create a new AI service resource, so we can create a new resource here, right? So yeah, so we can create a new resource group and the new resource responsible AI notice. All of those things we can choose, right? But we will not be doing that, right? So for existing AI service resource, or we can create a new resource, and we have to make sure that that resource is in the same region as this search resource, right? So both of them should be in the same region, and the billing of it will be separately. Like for the cognitive skills, the billing will be different, and for Azure AI Search, it will be different. So basically, Azure AI Search is using those resources, right? So those are built differently, right? And now let's see what we will do. We will use free limited enrichments only, but we can see what each skill is and what is the documentation for each skill. So if we go skills for extra processing during indexing, right? And here we can see what are the different kind of skills. So what is a skill? So skill is basically atomic operation that transform your content, right, in some way. So skill is some atomic operation that transforms your content in some way. So we have different kind of skills. So like we have different kind of operations that transforms your content, right? And these operations, this the output is usually a text based. So it is usually a text based for full text search, or it is a vector for vector search. So output is usually one of these kind, full text search or vector search. Then there are built-in skills. So built-in skills basically wrap API calls. So we have to use API calls here in skills. So it basically wrap API calls around existing Azure AI resources, right? So here inputs, outputs, and processing steps are well understood because these are built-in skills and these wrap API calls. So for these skills, we just need an Azure AI resource and connection to it. Everything else is here taken care by the Azure. So we just need to tell that this is the resource and this is the connection. All of the other processing and whether which input and which output to give is taken care by Azure. So these are the built-in skills. But there can be other skills also which are custom skills. So in custom skills, you have to take care of the input and output, like what should be the input and what should be the output. You usually like create custom skill using an Azure function app, and it takes the input and gives the output in a particular format so that it can be used by your skill set, right? It can be used by the pipeline of that, right? The enrichment pipeline. So that's why in custom skill you have to create your like if you want your custom functionality, then you will create an Azure function app. You can create other things also, like a web API. You just need something which expects input in a particular format and spits out output in a particular format. So all of those things will be like a web API or an Azure function app, right? In that you can have your custom logic, you can have your open source or third party vectorization model, because in built-in skills it will be using like built-in models, pre-trained models from Microsoft. You cannot have your custom model, right? And you cannot train on your own training data. And then the next is utility. So utility skills are basically they have no they are not charged, right? Most of the utilities are non-billable and they do not have any external dependency. Let's look at the AI skills. So here you have custom entity lookup skill. You can see this is metered by Azure AI Search, so the pricing will be in the Azure AI Search. So this looks for text from custom user defined list of words and phrases. Then there is key phrase extraction skill, which is metered by Azure AI Search, language detection, entity linking. All of this is for Azure AI Search. Entity recognition, PII detection, sentiment, translation, image analysis, OCR, vectorized skill. Vectorized skill is also there, right? And then document intelligence layout skill is there. Then with from Azure OpenAI, we have Azure OpenAI embedding skill. And then in the custom skills we have these two, web API skill and AML skill. So web API skills basically allows extensibility of AI enrichment pipeline by making HTTP call into custom web API. So we might have our custom web API. So this skill basically facilitates that, right? Then there is AML skill. So if you want to use your Azure machine learning model, then this skill will help in that. Then there are different utility skills, like we can see one of these, like if we have a conditional skill, so it basically filters based on the condition, right? So like here you can see this is the condition skill. So first in the input there will be a condition, when true and when false. So when true what to return, when false what to return, and this is the condition. So for example, let's see here, they have given an example. So this is the input, filter documents return only French documents. So this is the input in which the condition is that document language should be French, right? So, and when true, then it returns document sentences. When false, it returns null. And the output is also French sentences. So that is the target name of the French sentences. And this is the input. So you understand, like, based on condition, it's giving you the document sentences, or otherwise it is giving null. So this is basically where you put our inputs, outputs, and contexts, and then O data type is basically telling you that which skill it is using. So it is using this uh, conditional skill, right? So yeah, that we will see that what is this O data type. We will have the skills, right? And then in the context we have where the documents, like in what context we are referring to. So in the documents we have this document language which we want to check, right? Then this is another example for the same thing. Then we have this merge skill. So this is basically to consolidate your text from different, right? So like here you can see there is the brown fox jumps over the dog, and which items you want to insert, quick and lazy, and at what point 3 and 28, right? So it inserts the quick brown fox jumps over the lazy dog. So that is the merge text. So this is the merge text it gives, and it takes text item to insert and offset as input and gives this output. So this is our you know the skill set, the skill of the merge skill. This is the merge skill. Then there is a shaper skill which maps out complex type, right? uh, and then there's a split skill, split text into pages so that you can enrich or augment content incrementally, right? Then there is document extraction skill also. So all of these are utility based skills. So these are all the skills here, right? And we are choosing free limited enrichment. So because we are having a free trial, so that is why we are using that. So we will be using limited enrichment in which these kind of cognitive skills are there: detect language, extract people name, location name, translate text. So all of these we are using, right? So now afterwards what we have to do, also we can index maximum of 20 documents when we are using the free Azure AI service, right? In real solutions we will need a larger number of documents for our AI enrichment. Then after the attach Azure AI service section, we have add enrichment section. So in this, let's change our skill set name to this skill set. So here we will have a skill set name. So we will change it to this skill set, right? And then we will enable OCR and merge all text into merge content field. So enable OCR and merge all text into merge content field. So what it means is that if documents are image files, right? So from image files, you would need optical character recognition to read the text from there, or contain embedded images, or if we have a PDF document which has like embedded images, right, in it. Azure AI Search can merge text extracted from those images. So using optical character recognition, those text from the images will be extracted with the textual content of documents, and the textual content of document is already there, right? So text from images and text from the documents, this text is stored in a field called merge content. So all of this text will be stored in a merge content field, and this feature can only be enabled when parsing mode is default. So we choose parsing mode as default. That's why we can enable this feature. Then this is source data field. So here we have options of source data field. So let's see. In short, source data field is set to merge content. So let's see, we have to basically select merged content as source data field. But where does these fields come from? We can select metadata storage path also, right? We can select metadata storage name, metadata content type. So all of this because we selected, in our previous step, we selected metadata plus content, right? So that is why this is also extracted from our document. So when this document storage content type, so this is the content type of the document, which would be like file extension will be like .pdf, language will be like English, right? Author, what is the author of the PDF, title. So all of this are the like file type metadata, right? And these are the storage names. All of this has been extracted. So that is why this is automatically created by the indexer. Like these fields are automatically created by indexer. So we have content field also, and if we do not enable this, right, we will not have merged content field. But if we enable this, we also have merge content field. So merge content fields enable OCR and merge all text into merge content field, right? So we have all these fields, and these are automatically generated initially by indexer, right? We will create our own fields also. Then these are just the fields which are created by the indexer when it does extract from the data and the metadata, right? And let's see like what kind of these fields are. Like for the content, it might be the raw text. Merge content is the combination of content and all the OCR and everything, all the merged content. Then the storage name, like what is the storage name, storage path, that is the file of our name of our file, metadata, PDF. Content type will be application PDF, metadata language, last modified, storage size. So all of this is here, right? All of this we can see here: content type, language, author, title, file extension. So based on whatever file was, like if it was a PDF, there might be a different thing. If it is a image, there might be a different thing, right? And yeah, this is all the metadata and content extracted. So these are our source data fields. We will choose merged content because this will be our source data field for our skill set. Then this is the choose enrichment granularity level, right? So source field will be split into pages or sentences before enrichment. So if this is selected, then like if we select sentences or if we select pages, then the source field will be split it into pages or sentences before enrichment. So like there might be some skills which is like key phrase extraction. So you do not want it to give a like a 100 GB of data, right? That do key phrase extraction or in 100 GB of data. You will give it in chunks, right? So that the performance is good. Otherwise this will not make any sense, right? You want your data to be small to basically process. So that is why what is this is doing, it can do chunking like 5,000 characters chunk. It will make pages based on that. This is the page 1, this will be first 5,000 characters, then page 2 and page 3. Or sentences, you can like basically granularize based on the sentences. So before enrichment, select text cognitive skills will be applied at that level. So the cognitive skills like extract name, detect language, all of that will be applied on this granularity level, because we do not have that large size of document or that big documents, right? So we will choose source field default, we will not choose any granularity level, so that will be all the documents. So if we see here also, when we go here in the enrichment granularity level, when you define skill set in Azure Cognitive Search, enrichment granularity level tells the indexer the unit of data that get passed into your SI skills. So that is the unit of data. It could be like documents, so like the whole document will be passed, or it could also be like chunk level. So this really matters because of the performance. Small granularity improves throughput and reduces timeouts for big files, right? It increases the performance, right? Because if you give a whole PDF of 100 pages, right, then it will not be a good performance, right? The skill set will not have a good performance. But if you give just each one in page, like page 1 this, page 2 this, and give each page separately, then it would be a really good performance. So that is why we perform that, right? That is the enrichment level granularity, right? Then there is incremental enrichment. So let's see, we can enable this one also. So it makes more efficient enrichment pipeline by caching intermediate steps. So this is basically if you want to run your indexer again and again, right? So whatever you like, there will be these skills like key phrase attraction, language detection, right? Generate tags for images, generate caption for images. So all of these will be run on your data, right? And then the index will be created. But what if you change the data, or if you change something and now you want to rerun, right? Then if when you will rerun, then all of this will be again computed, all of this processing will again happen. So if you do not want that every time you run index or rerun the indexer, right? If you rerun the indexer, you have some changes, you add more data, and now you want to rerun your indexer, then every time you do that, there will be more same processing that you have already done it. So this, what this enable incremental enrichment does, it saves the intermediate data. So like the intermediate data, incremental enrichment makes more efficient enrichment pipeline by caching intermediate steps. So it caches the intermediate steps. So if we enable this, then we have to choose an existing connection, right? We have to choose which storage account and where we want this intermediate cache to store. So this is indexer cache location. So this is also, the name represents everything, the indexer's cache location, right? So this is enable incremental enrichment. We will not be doing that. So yeah, level of enrichment granularity level should be source field, which is the entire content. And then we have to select the following enrich fields. So we will select the image cognitive skills, text cognitive skills. So in these, what we want to check, we will check out the location, people name, key phrases, tags and captions. So let's select the image tags, generate caption name. Then there is people. Where is the people? This people name, location name, and I think key phrases. Yeah, people names, location name, and key phrases. And you can also see it also has a field name. So all of this will be stored in this field name people. We can change this also. Then key phrases, location, right? All of this will be stored here, right? So when you do incremental enrichment, then all of these things are here, right? Uh, yeah. So let's see. So we have selected our cognitive skills. So image cognitive skills and text cognitive skills. We want location, key phrase, and we will be storing that in these field names, right? So these require a field name. Checked items below require a field name, right? This is also written here. Then this is okay. We have added our enrichments. We have attached our AI services. Now this is an optional thing that we want. Do we want to save our enrichments to a knowledge store? So what happens is that AI search is used for search also, but you can also save this indexes in your knowledge store so that these can be used by different services, different downstream services. Like you can use it for analysis. You can use Power BI can use it for making these kind of dashboards, and all of this can be used. So you can see here there are like save enrichments to a knowledge store. So a knowledge store allow your project your enriched documents into tables and blobs. So you can store your knowledge, like these enriched documents into tables and blobs. So here you can see in our knowledge store, when we are going to save our enrichments, we have options of different projections: Azure file projection, table projection, and blob projections. So what does that mean? Like what does that projection means? So in very simple terms, projection is basically how you want to store your data, right? So projection tells Azure, how should I save these enriched documents into a connected storage? So we will again connect the storage account and tell like the location in which the storage account where it should be stored, right? Where should we store the output, the enriched documents? So if we select table, right here, if we select the Azure table projection, then we will specify Azure tables, right? In Azure file projection, we will specify the exact Azure file path in our storage account. In blob projection, we will specify the exact blob, right, where we want to store these enriched documents. So let's see. So in the projections, we have this kind of structure. Like there are three types of projection types, like tables, objects, and files. So in tables, you basically, if you have structured, if you want to store it in structured rows, right? So like tables, so this can be used by Power BI or Excel. So this is to analyze structured data. You can store your structured data into these tables, or you can store it as JSON object in Azure Blob Storage. So if you have JSON object, then you can use blob storage. So you will choose objects in that case, objects projection type. And then for files projection type, you want to like save enrichment output as serialized files like text or image files, right? Then you will go for the files projection type, and this is how it will look. So you will have these projections, you will have the storage account connection string, you will have this projections. So for like table projections, you will have the name of the table and then the source means like from the enriched document, which part of enriched document you want this in tables, right? And then again key phrases, it tells you like document pages, key phrases, right? So which part of the document, which part of the enriched document you want to store in that table that you are creating, key phrases, right? So this is basically table projection. Then there is object, we will know that this is the blob storage, and then there is a files, right? So this is how the projection works here, right? So these are the projections. Let's see what they are going to tell us. So save enrichment files, select only the following checkbox. So we have to check the image projections, we have to check the key phrases, document, and documents. An error will display, you will resolve that shortly. Okay, so error will display, you will resolve that shortly. Okay, so we have to select the image projections. So image projections, right? Then we have to say documents projection. Then we have to uncheck these and only check the documents. Let's see, image projection, Azure file projections, we have to do image projections and documents and key phrases, right? and then in Azure blob projections we have to select the document. So all of these errors, let's solve these. So choose an existing connection. So select the documents container. This is the only required to select storage account in the browser interface. You will specify different container name for the extracted knowledge asset. So let's do that. We will basically connect to our storage account. This is only required to select the storage account in browser interface. You will specify different container name for extract knowledge assets. So extracted knowledge assets. Okay. So let's click on choose an existing connection, and here we will choose our search storage, and then for our container we will choose documents and select that. So we have chosen that, and now that error has gone. So this is the whole path of that storage account. Then the next is the container's name. In the container's name we will change it to knowledge store, right? So we'll change it to the knowledge store. Now this is okay, and now proceed to customize target index. So the next step is customize target index, where you will specify the fields of your index. So now let's go to customize target index. So we have imported our data. Now we have to name our Azure index name. So we will name our index as Margi, the same Margi's index. And then ensure the key is set to metadata storage path. Leave the suggested name blank. Ensure search mode is analyzing infix matching. So as you can see, first of all, we have our index name. We provide a default index for you. You can delete the fields you don't need. Everything is editable. But once index is created, deleting or changing existing field will require re-indexing your documents, right? Now let's see. We have this index name, so that is the name of the index, right? Then we have this key, so there can only be one key field in the index. It has to be string field and retrievable. So this field has to, there is only one field which can be key. Key is like primary key, right? So that should be unique identifier for each document. Which field we want as primary key. So that is the question of the key, right? And this should be retrievable. Retrievable means you must be able to retrieve it, right, to show it. So when you search something, results are retrieved, right? So that is what we mean by retrievable. So it should be retrievable, it should be unique, it should be a string field. So that like type of it should be string, and the field represents a unique. So we have chosen metadata storage path as our uh, the key field, right, because the path will always be unique. Then the suggested name. So whenever you search, there is like, whenever I am searching here, like on the Google, hello, so hello Taylor. So there is like results, all of these results, Taylor Johnson and everything, like so yeah, all of this can be, this is basically typed, and like it suggests some results, right? So that is basically the thing here also. That is the suggested name, right? Whatever you want to name your suggested. And then this is basically, if you name or suggest something, then these are the things that it will come here also, because you are naming your suggested, so you are creating a suggested for all of these fields. So you can see all of this in suggested came here, right? So if we do, but we do not, we won't create any suggester here, but we can create suggester. And then this is a search mode. So in this suggester, how it will suggest, so this is basically search mode, the strategy used to search for candidate phrases, right? The only mode currently supported is analyzing infix matching, right? So this is basically for the this suggester. And then these are the fields here. So before that, let's see what we have here. And so retrievable. So what does retrievable means is, can this field be returned as search result? So if it can be returned as search result, if this field can be result as search result, then it is retrievable. So if we come here and if we see this key phrases, so are they retrievable? Like, can we see that, right? If we search for a key phrase, then that key phrase retrievable? Or even if we search for key phrase, then we want some text Is that retrievable? So retrievable means can that be shown in results? Then searchable. Searchable means can you perform a text search on that field? So if you can perform a text search on the field, then it is searchable. Filterable is can you filter? So yeah, so searchable is basically keyword matching, and retrievable is basically show user the results. Filterable, if a field is filterable or not, means can you perform filtration on that? So like price greater than 100, right? So price is a field, and you can you perform filtration on that? So like only those results will be shown in which price is greater than 10. But if the field is not filterable, then you cannot perform this kind of operation. Then sortable, can you sort the result based on the field? Then this is facetable. So facetable means can you build aggregations based on that field, or can you show it by category? So when you go on Amazon, you select some filters, right? So those filters are basically facetables. So you select them and you basically filter by brand, Apple 10, Samsung 8. So this brand is basically facetable. So this field is facetable. That's why it has distinct categories like Apple and Samsung, and we have the aggregations of that also. The Apple is 10 products for Apple and Samsung's 8 products, right? So this is by basically filter by brand. So this is an example of faceable. So that is what we mean, like creating those categories and aggregations, right? So which fields can be used as faceable, right? Then there is suggester basically is autocomplete, right? Autocomplete, so it suggests something so that you can autocomplete it, right? Then there is analyzer. So this basically tells how text is broken into searchable tokens. So how the text should be broken into searchable tokens. So that is basically our analyzer. So here if we can see, our analyzer is standard Lucene, but we can choose another analyzer also, right? There are a lot of analyzers here. So for analyzer, we are the standard and the default one is Lucene, and we have different for different languages like Turkish Lucene, Thai Lucene, right? And then we have this text, like these are the fields that we have in our index. So these will be the fields in our index, and these are the custom fields that these are the fields that were created when the document was being cracked. So document was cracked means all the like all these things, content type, language, title, and the size, and the all these things were being extracted from the document, right? Like merged content and these kind of things. And then there are others which are basically our AI enrichments, like people detection. We have the people field. For key phrases, we have key phrase field. Image tag, we have image tag field, right? So now what we will be doing is we will be basically checking which one is retrievable, filterable, sortable, facetable, searchable, right? And which one requires suggester or everything. We can also delete these fields if we do not want such some fields. So here we can customize, but after this point we cannot customize our index. So after this point, if you want to again create a new index, you have to make changes to indexer. So here we can see we provide a default index for you. You can delete the fields you don't need. Everything is editable. But once the index is created, deleting or changing existing fields will require a re-indexing your document. So right now you can edit your fields and basically create an index, but afterwards you cannot edit it. Then you have to create a new indexer and again index, right? And again perform that whole operation to create a new index. So right now let's see what are the fields. So all of these fields from metadata storage size, metadata storage last, so all of these should be retrievable. So let's see, uh, let's put this in a different mode here, right? So we can basically plug these. uh, so metadata storage size, so that should be retrievable. Metadata storage size, metadata storage last modified, metadata storage name, so these are retrievable. Then locations, people and key phrases, so location, people and key phrases, merge content, all of these should not be retrievable, right? So only people, location, key phrases, and metadata storage, and size last modified, and name, right? So only these should be retrievable, others are not retrievable. So Also these all are filterable also, right? So these all are filterable. And then sortable, all of the first one are sortable, so we can only sort by these. And then facetable, none of them are. Then searchable, so metadata storage name, metadata storage name, and these are basically searchable, but these one are not searchable. Then these are retrievable, filterable, sortable, and these are searchable. So we have configured all of these, which fields should be retrievable, filterable, sortable, and searchable. And now we can go to create our indexer, right? So the next step is, let's see, where are we, right? So after this, what we have to do, we have to create an indexer. Indexer name is Margez indexer, right? So yeah, this is the index name, not the indexer name. Next we will create an indexer, and then the name of it will be this, leave the schedule set at once. So let's see here. So schedule is at once. So if you put it hourly, then automatic change tracking for blob data sources, right? So if daily, so it basically, this indexer will run based on the schedule. It will run daily, it will run on a custom schedule if you want a custom schedule, right? So it will track the new data, right? And based on the change tracking for the blob data sources, if there is any change, then it will run the indexer again, right? So that is what we mean by schedule. So we only want once because this is for testing purpose. And then we have to click on submit. Select submit to create data source. So we have created our data source. We have added cognitive skills. We have added a like also have our target index, and then we are creating our indexer. So that's what is said here. Indexer run automatically and run the indexing pipeline. So this extracts of documents metadata fields and content from data source. So that was our first step. Then it runs skill set of cognitive skills to generate additional enrich fields. This was our second step, and then these map the extracted fields to the index. So that was our the third step. And then we save the extracted data assets to knowledge store. So this was also in the third step that we perform this thing, right? So let's click on, there are advanced options also, right? But we will just click on submit, and then it will creating skills created successfully, and then it is doing its thing, right? Let's wait for it. And afterwards, what we have to do, under search management, view the indexers page, which should now show the new indexer. Wait for a few minutes, click refresh until the status indicates success. So yeah, so it has been created now. Let's do a refresh like they said, and then we will go in search management view. So this is our search management view. Here we can click on indexers. So we will have different indexers. Yeah, this is Margay's indexer that we have created. If we go into indexes, then also one index will be created for us. So yeah, this is the index that we have created, right? So right now it's nothing. So this is the indexer. These are the data sources. So let's see for the data sources also. So this is the data source, right? And then the skill sets. So this is basically search management. So we have skill set also. So view the indexer page. We should now show this newly created this indexer. Select refresh until the status indicates success, right? So this indexer, let's see here. So it shows that the status is success. So this indexer has been created, right? And let's go back. So what is the next step? So it just needs some refresh. So now if we have refreshed, and now we can see that we have this our index. So Magi index. So there are document count of 6, right? And this total storage is this. So that is vector index. So that we do not have it, right? So we have this. And now what we are going to do is we are going to our search explorer, right? So we will go to our overview page. So this is our overview page. We have seen all the indexes, indexer, data sources, right? Even the skill sets. Now we will go to our overview page. So in overview page, there you can see this, this kind of box. Click on search explorer, right? And when we click on search explorer, now we have to select our index. So we will be selecting this Margate index, and now we will search. So for search, first of all, we will search for everything. So we will click on star and click on search. And now you can see this is our search. And in our search, this is the count, like how many results are there. So there are 6 results. And in this search, you can see we have locations. So all the locations, the key phrases, right? From all the documents, because this is the star search. So we have location, key phrases, then there is content, metadata, storage size, last modified. All of these are were retrievable, so that's why all of these have been shown here. Locations, key phrases, then again search score, location, key phrases, then again all of this, and the content also. So content was also retrievable. So all of these fields which we set as retrievable, only these are shown here, right? Other fields are not shown here. And you can see the whole document is like this, because for each document it is taking this. So these values are for each of the documents. So this is the first document, as you can see here also. If we can see this red lines also, 1 2 3 4 5 6 documents, right? And you can also see from here also. So these are the results. And what we can do here, we can change the view. So we can change view from query view. So this is query view. We can change it to JSON view, and in JSON view we can have this thing also, search, true, and everything, right? So this is our JSON query editor. So now let's see what we have to do. First of all, we have to search star, right? That we have already done. And we have to notice o data field, right? This is the count of the field. And the next thing we have to do is we have to copy this select parameter. So there is a select parameter also. Beside count, there is select parameters. This will select what should be in the retrievable fields, right? Like which retrievable fields should you show in the results. So if we click on this right now, see, we have locations, we have key phrases, we have people also, people, right? So we have those things. But in this, if we search this, then you will see now we only have locations, and we only have metadata storage name. We do not have anything else in values. So in values, we have this only, right? So the first value is this one, which has metadata storage name and location, because we specify only that, and others are not shown. That's why. So the next thing is we can do that with the key phrases also. So we can add key phrases. So let's add this one, or just let's just put it here, like type it here. Key phrases, key phrases, and search. Then see, this time it will also have key phrases. So metadata storage name, location, and then key phrases. So this result is there, right? Then yeah, then again for each of the document. Then we can also add now condition. We can add a condition of New York. So only those search fields which have New York. So this New York will be searched in all the search fields, right? All the fields that we have put it as search field, it will be searched in all of those, and it will return only the documents in which that was visible, right? So let's see here, search. So as you can see, how many documents we have in this time. Let's see, in the at the top we have 3 documents, because only 3 documents contain New York. And in locations also you can see there is New York, New York City, New York hotels, New York, right? The thing is, we have this locations also, but even if we uh, you know we just remove this New York locations here also, even then it will show those, like it won't show the locations, but it is showing us the same thing here, because these are the retrievable results, right? So you can understand that also. that retrievable fields and searchable fields, those are different concept. Searchable fields means on which fields you are going to search and the results will be returned according to that. Retrievable fields is basically which fields you can see, right, in the results. And this select statement is like one more added layer which filters out which result should be there. And search field is basically the fields on which we want to search, right? So that's the thing. And count is true. Basically count true means you will get the count here, data count, right? And the next thing is let's try one more query. In this query we are adding filter also. So in this filter we are saying that metadata storage size should less than 3000, not 3000. Let's see what's this. It's 1000, 380,000. So metadata size should be less than 380,000. Then let's search this. So this is basically telling you the filter. So there is only one document which is less than this. So yeah, that is the everything. This is our search explorer. We can have this search, count, filter, and select. So all of this, if you know SQL, then search is like basically what you want to search, right? So this is a different thing, like from which database. You select from. So this search is basically from. This count is basically aggregation, right? This select is basically select in SQL, and this filter is like where, right? So yeah, you can also compare this to like SQL syntax, but yeah, the search, count, select, and filter, all of these are the search in the search explorer. Now the next thing we have to do is this is in bytes. So this 380,000 is a bytes, right? So this will be a kilobyte. So it is uh, something like 3.8 megabyte. So if it is less than that, yeah, then we have to create a search client application. Now that you have a useful index, you can use it for from a client application. And we will be using a REST interface for submitting our request and receiving responses in JSON format over HTTP. And you can use software development kit also, right? We have for C hash and Python. Then we have to go to our overview page again. So let's move to our search resource. This is our search service, and we are in the overview pane, right? So in the overview page of the Azure AI search, there will be a URL value. This is the endpoint of your Azure search. So let's see here. So this is the URL. So this URL is basically the endpoint of our search. So search.windows.net. So this is the endpoint, the URL. This is the endpoint for our resource, for our search service resource. So that is search.windows.net. This is the endpoint for our search resource in our URL value, right? URL. Then in navigation pane on left, we will see our keys. So if we go to navigation pane on left, and we have to go to our settings. So in the settings, there is an option for keys. We will click on keys, and here you will see there is a managed admin keys and there is managed query keys. So there are two types of keys. So managed admin keys is basically for our resource. Like every resource has a managed keys, right? Uh, and then there is query keys. So those are basically different keys, right? So query key is used by client applications that only need to perform search queries. So client applications only want to perform the search queries. They don't want to create an index. They don't want to do anything related to indexer or everything, right? They just want to use that search explorer. So for that we have the query keys, right? So query keys is just for performing search queries, whereas admin keys is used to create and manage search resource. So this is admin work, right? So this is basically you are creating the resource, whatever we have done, right? We create the resource, we manage the search resource, we make an indexer, we make index, right? But our client applications don't need that. Our client applications only want to perform search queries, right? So for them there is a query key here, right? There is one query key already, but you can also add more query keys here. Now the next step is to go to our Azure portal and open the classic version of Cloud Shell, clone this repository, and then create our virtual environment and install these library Azure Identity, Azure Search documents. And then we will modify our environment variables with the search endpoint, query key, and the index name. So all of these you will be needing, and then we will open our code file. So let me do all of those things. Hi guys, so I have set up all of this, and these are my environment variables. So I just put this search endpoint from the Azure search endpoint, right? And then the query key and the index name. So these are all, and let's control S and control Q. So yeah, so now let's go to our code. So we have to go to code search app.py. So let's click on code search app.py, right? So this is our code. So let's try to understand this code. And yeah, so first of all, what we are doing in this code, we are importing Azure search key credential, and from azure.search.documents, search documents, right? We are importing a search client. And in this search client, what we are passing the endpoint of our search Azure search resource. We are passing the index name, right? The name of the index we are passing. And then we are passing the Azure key credentials, which is the query key, not the administration key, that is the query key. So these are two different things which we are doing. We are passing the index name, and we are also passing the query key as a credential and the search endpoint. So all of those things which we have configured in our environment variables, right? And then we are creating that client. Here we are running an infinite loop in which we are asking a user to enter a query or either enter quit, right? And we are converting the query text, right? Please enter a query. So yeah, so here we are just taking the query text, right? So after that, what we are doing, for clear console, we have this CLS, okay. Then with our search client, we are calling its method dot search, and in dot search method we are specifying select, like whatever we were doing in Explorer, order by, so which fields we want to order by, include total count, so whether we want to include total count, and search text, so which is the search text, which is the query text, whatever the like the user has specified. So this is the found document. So the basically all the documents which have been found will be in this the result. So this is search client dot search. So this is very simple method, right? We are doing search and the method name is also search, right? Then in the found documents, we will loop on each documents. On found documents dot get count basically gives us the number of documents that were found. So get count is basically very easy. Here we get include total count, and here we are just calling the method get count. Then for each document we are like extracting their field name. So we have this metadata storage name, we have the locations, we have people, right? And we have key phrases. So we are just extracting the specific fields from each document and we are printing that, right? So that is very simple function, right? We are just azure.search.documents. We are importing our search client. In search client, we are passing endpoint, index, and the credential, and then we are calling dot search method, which is returning some documents, and then we are getting dot get count and running the loop. And in the loop, we are just printing each of that the fields like document, metadata storage name, document location, people, key phrases, right? So let's try to run this. Let's say control X, no, control Z, control S, control Q, right? So in here, let's see, okay, CLS, right? So yeah, now we have seen all of this. We just need to enter this command and run one of our query with query as London's, then flights, and then we will see. So Python search app.py. So it is asking us to query. We will query London. So here you can see the first document which mentions London is with the locations are these, in which location is London also. Then these are the people. These are the key phrases, right? So this is the document, and then this is again one of that document, London brochure.pdf. It also has London city, people, key phrases. Total number of documents were 2. So search return documents are 2 documents, right? So that is all, right? And now let's do CLS. Then enter a query. So the next query we want to enter is flights. So let's enter flights. FLIGHTS flights. So here you can see we only have one document. So it has mentioned people, it has mentioned, so that document is company info.pdf. So in that we have this people, key phrases, right? All of those things, right? Now let's do CLS again, and then let's type quit and CLS again. So yeah, close the cloud shell, returning to the Azure portal. View the knowledge store, right? So we should view the knowledge store here, right? So whatever knowledge store looks like. So to view the knowledge store, we have to go to our, let's see. So for viewing the knowledge store, we have to go to our like the Azure Storage account that we have specified in the skill set definition. So in the skill set definition, we specified the same storage account. So we will go to that storage account. So let's go to that storage account. So this was the search account storage, right? And in this storage account, what we will go, where will we go afterwards? So we will go to this storage browser, right? We will click on storage browser. So here we have all our, uh, the things, right? So we will click on blob containers in this, and in blob containers we can see there are two containers, knowledge store and margin skill set image projection. First of all, we will click on knowledge store, and then we can see that for each file we have 6 files. For each file there is something here, right? And similarly for the margin skill set image projection also there are like some things, right? Like three files, three there are six uh, like blobs, right? Then the next thing is what we have to see here. So we have gone to our storage browser tab, and we have expanded the blob containers to view containers. We had two containers in our blob containers. One is knowledge store and another is skill set image protection, right? So we will select knowledge store and we will see each index document. So open any of the folders and then select the object projection.json file. So the object projection JSON file, and we will download it, and we will see that it looks like this document. So this JSON file contains representation of the index document. The index document, it contains the representation of that, including the enriched data extracted by skill sets. So yeah, this is how it will look like, right? This is the formatted one. That would not be formatted, right? So let's click on knowledge store, and then let's click on the first one only, and then we have this object one, right? So let's okay, so what we have to do afterwards, we have to download this. So to download this, we click on this three dot button and then click on download. Then it will download it. We will open it. Let's open this, and we can see now this is the, sorry about this. So metadata storage account type, right? Then these are the bounding boxes also for words, for text, for language. So this is all that has been extracted, right? Then this name, everything is here. Object project dot projection.json. So this is a very long file. So let me put this into control A, control X, uh, maybe JSON beautify, something like this, JSON formatter, and upload data or format. Okay, let's, so you can see here it is more formatted. So you have the content type, content size, all of those fields which you have. Merged content is also here, right? We have key phrases, entities, images, right? And in images also we have all of those things, description, captions, hide, data, all of this is here, right? So yeah, all of this is on whatever our final document was. So final enriched document pass, so that is in this. So each JSON file contains a representation of an indexed document, including indexed data extracted by the skill set, right? So and the more fields. So the ability to create object projections like this enables you to get enriched data objects. So these enriched data objects, we can use this in our downstream solutions like data analysis solution and those kind of solutions. So these are very helpful in that. Then next is view file projections. So if we want to view file projection, then we will go back here, right? And again we will go back here, and again we will go back. All store blob containers. Uh, so we have this Margin skill set image projection. We will click on this, and this is also for each document there is one. We will download one of this. So let's see, click on this, and then this is the we will download this. Then let's download it, and let's see, this is an image, right? So this basically Margie's travel. So this is basically an image that is extracted from that PDF document, and it looks nice, right? So yeah, let's see here in views projection what we are saying. So in this Margee skill set image projection, so this is an image projection, right? And we are saying it, this is the file projection. So file projection defined in skill set create JPG files for each image that was extracted from document, and each folder contains one image. The ability to generate file projections like this make indexing an efficient way to extract embedded images. So if there are large volume of documents, of PDF documents, and you just want to extract the embedded images from those documents, then this view file projections can be used, right? Then the last is view table projections. For that we will go to our tables, right? And let's go to our tables. So here, tables, and then we will see there are two tables created. One is Margie's skill set document, another is Margie's skill set key phrases. So this table contains row for each document that was indexed. So let's see. So the Margee skill set document, this contains row for each document that was indexed, and this also key phrases table also contains a row for each key phrase extracted from document, for each key phrase, right? So let's see here. So if we go to this one Margee skill set document, we can see this is the partition key, row key, timestamp, document ID, entities, merged content. So that is our field, metadata author. So all of those fields, metadata language, storage, right? All of these fields are here. Sorry about that. Okay, back. Uh, Let me go back to the, okay. Let me go back to our storage account. Sorry about that. Yeah, now we are back on our page. So now the next is Margee skill set key phrases, right? So if we click on this, we can see this kind of table, which is like in which there is like key phrases also, right? Best travel experts, am all of one. So for each key phrase there is a one row for each key phrase, right? Whereas in this case there was each key phrase for each document, so that is why there are like just six rows, right? 1 3 4 5 6, right? So tables. So yeah, the ability to create table projection enables you to build analytical and reporting solutions like Power BI. We can use that in like we can use the table in there, right? To query relational schema, the automatically generated key columns can be used to join the tables in queries. For example, to return all of the key phrases extracted from a specific document, right? So yeah, this can be used for this also. So these are three kind of projections that we got: table projections, which we got in our table storage, and then file projections and object projection, which we got in our blob storage. And this concludes our lab.